Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's DevOps.com webinar, brought to you by TechStrong and DeepFactor. My name is Cody J. Brown, and I'm the host of TechStrong Learning. We have an exciting discussion ahead, but before we begin, I have just a few housekeeping notes. First, today's discussion is being recorded, so if you miss any of the session or you'd just like to share it with a friend, the on-demand recording will be made available shortly after the webinar concludes. If you look to the right side of your screen, you'll notice a Q&A tab. This is where we want you to direct any questions that you have for our speakers today. And if you look at the chat tab, this is where we want you to add to our conversation. Or if you don't have anything to say, just let us know where you're tuning in from. And finally, at the conclusion of our webinar, we will have a drawing for 4 $25 Amazon gift cards. So on to our topic today. We'll be discussing developer security, building security culture into your engineering team. And I'm joined today by Jim Routh, board member, advisor, and investor at DeepFactor, Kiran Kamity, founder and CEO of DeepFactor, and Andrew Horrigan, technical product marketing at DeepFactor, and he will also be serving as our discussion leader today. So with that being said, Andrew, I'll go ahead and turn the floor over to you. Thank you guys so much for being here with us today.
Sounds good. Thanks, Cody. Really appreciate you kicking us off there. Welcome, everybody. Like Cody said, we're going to be talking a little bit today about developer security and the idea that, by building out a developer security program at your organization, you'll be better prepared for the sort of modern challenges that a lot of security and development teams are dealing with. As we all know, things like cloud-native applications, Kubernetes are quickly increasing the pace of which applications are being released. Applications are more complex, right, because of this. And with this sort of change, developers are being asked to resolve more of these vulnerabilities and supply chain risks in development, right? AppSec simply can't scale, and developers are being asked to take on some of that mantle of responsibility. So in order to kind of discover and understand those risks, you'll see a lot of organizations, there's a big buzzword out there called DevSecOps, and the idea that by shifting left, you're better prepared to sort of deal with those problems. So, we at DeepFactor are very passionate about that sort of that shift. We strive to help companies implement product and sort of solutions to take that on. And we were excited to have Jim join us today to kind of have a conversation around that because he's pretty well known and renowned in his area of expertise. I kind of want to give Kiran a chance to introduce himself and then go ahead and introduce Jim so we can kind of get this conversation kicked off.
Awesome. Thanks, Andrew. So nice to meet you, everyone. Thank you for having me here. I'm Kiran Kamity. I'm the founder and CEO of DeepFactor. And today I have with me Jim Routh. I don't think I can do justice to Jim's excellent background in just a minute of this introduction, but I'll give it a try. He's one of the most well-respected chief security officers in the industry. His work involves implementing cutting-edge cybersecurity programs in large public companies, primarily centered around digital transformation, leveraging data science to shrink attack surface, increasing friction for threat actors, reducing friction for employees and customers in that process. He specifically served as the CISO and in senior security leadership roles at companies like Amex, Aetna, CVS Health, MassMutual, et cetera, and serves as an advisor, board member for numerous security startups, advisor to various venture capital firms. Such a fantastic background. Welcome, Jim. It's an honor to be here with you.
Kiran, I'm happy to be here with you, and thanks for the very nice introduction. I got bored, but it was a nice introduction. I appreciate it.
Can you confirm every single item on this list for us, please?
Everything he said was true.
I had to memorize it last night, and there were too many things to memorize.
That's what, when you get two things are reality. Number one, I'm old. Number two, I'm known more for what I formerly did than what I do today. Because literally today, I spend most of my time playing pickleball and having fun. But every now and again, I do a little bit of work. So, which is a real counterbalance to the way it was when I was protecting an enterprise 24/7. So I'm liberated and feeling pretty good about it.
That's great. Awesome. So before we get started, I wanted to do a little bit of an icebreaker. So, I kind of surprised the guys with this just last week. But there's a game when I was growing up as a kid that's called, I think it's Kiss, Marry, and Kill. Which I'm not advocating that we play that game on this call. But I wanted to put a little kind of a unique spin on there. So instead of Kiss, Marry, Kill, I kind of want to get your guys' impression on which of these sort of security incidents would you have liked to manage as a CISO? Which one would you want to experience as kind of like a security practitioner, the guy, the boots on the ground? And which one would you have loved to have prevented as a consumer? So someone that might have been impacted. So the 3 incidents I want to talk about, which are pretty timely, are Solarwinds. So we got the supply chain hack that happened towards the end of 2020. We've got Log4j, right, which I think we're still all dealing with. It was our Christmas gift for 2021. And then the Colonial Pipeline ransomware attack, where the pipeline was actually held hostage. I'm kind of curious, which one of those would you have preferred to manage as a CISO? Which one maybe would have impacted you the most as a consumer, so you wish you would have prevented it? And which one would you prefer to have dealt with, actually had to fix the problems? And I'm just kind of curious what your guys' impressions are to talk about those security incidents.
Yeah, so I'm going to start with Colonial Pipeline would have been the most interesting one as a CISO. And here's why. And, I mentioned that it's kind of liberated now that I'm retired as a CISO. So the next piece of information I'm going to share, I've never shared publicly because I wasn't allowed to share it publicly. And I thought it was prudent not to share it publicly. But frankly, now I think it's the practical reality.
It doesn't impact your pickleball score, is what you're saying.
And it does not impact my pickleball scores. Thank you, Andrew. That's well done. So here's the deal. The worst thing you can do as a CISO is have a policy that says that you will never pay a ransom when there's a cybersecurity ransomware attack. The worst thing you can do from a policy perspective is write a policy that says that you will always pay a ransom if an employee is kidnapped. Now, having said that, even though you never want to write this down, what you want to be in lockstep with your senior executives, primarily your CEO, is this: we will never pay a ransom for a ransomware attack, and we will always pay a ransom for a kidnapping that impacts an employee or member associate of the company. And that needs to be baked into the fabric of how an enterprise responds to those 2 types of incidents. But it can't be policy because you can't get away with writing that down and then having regulators review it because it's so controversial. But it does give, and this is the whole point, in a security incident, you want some sort of stake in the ground that allows you to respond accordingly to the incident. And this is that stake in the ground. And so the implication of that stake is that we have to prepare our backup and recovery capability, anticipating that we're going to have ransomware attacks, and be able to quickly recover from that, investing in the infrastructure necessary to do that. That's separate from the investments that we've made for most enterprises over the last 2 decades, speeding up data replication and recovery. So we've spent a lot of money improving our data replication and recovery capability, which now adds an extension of the attack surface for ransomware attack. So, and in fact, most of the ransomware as a service attacks that we see today attack the backup and recovery capability first because it raises the probability of paying a ransom. So we never want to pay a ransom. I saw a statistic recently, it's something like less than 20% of ransomware payments result in actually getting your data back. And I think it's over 60% of the time you get attacked by the same threat actor again. So paying a ransom is easy from an insurance company's perspective, who's willing, to cover that. But it really is adding gasoline to fire to drive the prevalence of and the probability of a ransomware attack going forward. So rule of thumb, that's, to answer your question, Andrew, that's the incident that I would have liked to have dealt with as a CISO because it really puts those two fundamental stakes in the ground, at least one of them in this case.
That's interesting. As someone who lives in North Carolina, I would have preferred to have prevented that one because I think I was without gas for about 2 weeks. So that was where I was going with that one. Kiran, I'm curious, how would you have answered this question? And thank you, Jim, for those insights. I don't, that was not something that I anticipated getting into on this call, but I think it's very interesting to learn how something like that needs to be managed from the inside and how you kind of have to bake it into the fabric of how your enterprise operates in that sort of high stakes game. Kiran, thoughts?
Yeah, thank you, Jim. I learned something there as well. From my perspective, given that I'm very passionate about creating secure software, if I was a CISO, I would look to mitigate the Log4j, items, because that will give us an opportunity, the enterprise, an opportunity to not just fix the problems with where your dependencies lie, but will also help, in the context of this particular conversation, the engineering teams get their act together and working in conjunction with the security counterparts or having security kind of embedded to their team, both from a process and tooling perspective, so that they can end up creating secure applications and make that a habit going forward, staying on top of the issues, both zero-day as well as known CVEs that may exist. When it comes to dealing, out of the three examples that you gave, SolarWinds, Colonial Pipeline, and Log4j, as a CISO, I would like to probably prevent Log4j because of the example because of the reason that I just gave. I would probably, as a security practitioner, I would probably learn the most from SolarWinds because, at least my thinking is that because of the bake time that it got, between the time when SolarWinds Orion product was actually compromised or injected with malware to how much time it took for the bad actors to kind of penetrate into the organization through lateral penetration, it probably would give a security practitioner a lot of learning around which lateral resources in the enterprise that was penetrated to, how to protect that going forward and things like that. And then as a consumer, I probably would want to prevent the Colonial Pipeline ransomware attack because I wouldn't want to, there was a 6-day outage without gas, without flights, and so far in the Southeast. So I probably wouldn't want to have that problem.
That's fair. That's fair. Well, thank you guys for your insights. I really appreciate it. I just thought it would be a fun way to kind of kick it off and discuss some of these high level, security incidents that happened over, 2021, 2020. The other reason I wanted to start that way is I feel like we focus a lot on the outcome of these security incidents. So we talk about, with the case of Log4j, what was the root cause? How do we actually mitigate this? And you kind of see the sort of ripple effect across Twitter and LinkedIn on people trying to manage the fallout of that. But we don't talk a lot about the sort of things that are happening before the security incidents. So, as someone who was a CISO and as someone who is a CEO of a company, what I'm really curious is, how did these security events kind of expose maybe broken processes or mitigations that didn't work? Or, I think, Jim, you kind of talked about it a little bit with the ransomware, but I'm kind of curious, how do these events really kind of cause enterprises to do some self reflection on the events themselves?
So let's start with one principle that says that cyber resilience for an enterprise is defined as the ability to respond quickly and recover from a cybersecurity incident. Now, the reason I say that is when I started as a CISO 20 years ago, my CEOs would say, no incidents. We don't want any cybersecurity incidents. And I'd say, well, all right, we'll have to quadruple our budget. And the response was, well, we're not going to do that. So I said, okay, then you got to deal with the fact that we may have cybersecurity incidents. So then the default was, it can't be on a front page of New York Times. And I literally had, when I was at DTCC, that's what I was told. We cannot have a cybersecurity incident on the front page of the New York Times. Now, here's the right way to think about incident response. The right way to think about it is to bake into the incident response process a step that's called apply lessons learned. And the way to do that is actually during the incident. And the incident response, that process has to be practiced time and time again by multiple stakeholders, including business leaders, the CEO. They have to be part and parcel and comfortable with the techniques and approaches that are baked into your incident response process. Now, if you look at an incident as an opportunity to improve your practices and therefore celebrate what you can learn from the incidents to apply to more effective practices, you're taking a giant step towards enterprise cyber resilience. And that's as good as it gets. And so your incident response process should have lessons learned applied to improve processes going forward. Now, the beauty of this is you can learn from someone else's incident. It doesn't have to be yours. It's more painful when it's your enterprise's cybersecurity incident, but frankly, you can learn from someone else's. Case in point, I dealt with firsthand, a buddy of mine, a good friend of mine, decided to take a vacation for the first time, and first time in a long time. And he took his daughter, I think she was 16, 17. She had just got into college, and this was like her big gift, and they went to Machu Picchu. While he was at Machu Picchu, unfortunately, NotPetya occurred, and his company was significantly impacted. They lost about 15,000 servers that were bricked in 90 seconds. So that just gives you a sense of scale. While that was taking place, he was at Machu Picchu. So I was actually talking to his team, which were spread out all over the world, as part of the recovery process, because I was the chair of the Health ISAC at the time, and we basically used the information that his team provided to identify how the spread continued across the enterprise and what steps you can take to mitigate it as an enterprise. And that information was tremendously valuable to lots of other organizations. We learned that directly from the incident that occurred. That's the good news. The bad news is I was a CISO at the time, and I did not apply the lessons learned aggressively enough in my next CISO gig, which I really should have known because I was part of the NotPetya experience. But I really didn't do a good job, specifically around protecting access to the build process and ultimately the code repository management system. The repo access is what ultimately got compromised in Solarwinds. And Solarwinds, I was using, my company was using Orion software at the time. We were fortunate in that we didn't get hacked because we had an older version that wasn't vulnerable, which, I didn't even know we had Solarwinds Orion in the enterprise.
I think that was the mitigation to Log4j as well. It was just make sure you were running an old enough version that you weren't impacted.
Yes, and so there shouldn't be reward for having archaic technology, but in this case, that's exactly what happened. Here's my point. My point is, I didn't do a good enough job learning somebody else's incident. And so we, as an industry, as a set of cybersecurity professionals, we have to think that, look, incident response is a gift. And so we should put our best effort into applying lessons learned to make our enterprises more resilient on a continual basis going forward. We'll never prevent. Think of it this way. In the history of humankind, we've never had a period without crime. Never. So I guarantee you we will never have a period without cybercrime. Okay, yeah. So the whole idea of making cybercrime go away, it's not fathomable. It's not going to happen. So
yeah,
we have to go ahead.
Sorry. No, I was just going to say, I really like how you're framing this, this idea of a security incident being a learning event. As someone who went through business school, right, you always do case studies, and the idea of a case study is to kind of prepare you for these major events that could happen to you as someone who's in the sort of business and enterprise world. And I think, one of the things that we really wanted to get into today is this idea that the security incidents are highlighting a need to maybe catch the problems earlier in the sort of life cycle of maybe the application. So I know, for example, IBM does a really good report on the state of the breach, right, where they talk about, how certain breaches are the direct result of application security incidents, right? So SolarWinds is an example of the CI/CD pipeline being hacked, or you can look at Log4j as an incident where the application itself, the Java being the attack vector. So, Kiran, I want to give you an opportunity, as someone who's leading a cybersecurity company, in DeepFactor, developing, the next generation of application security tools, what are those security incidents that you might have learned from, and what are the sort of trends that you saw in the market that kind of led you down this path of, hey, we need to take developer security more seriously?
Yeah. Before I started DeepFactor, I had sold a company to Cisco. It was called Container X. And the goal for that company was to enable enterprises to create a containerized infrastructure in their premises or in a self-managed fashion, kind of like a rancher, if you will, for those that are familiar with the cloud native landscape. Container X was a company that created that. That was acquired by Cisco. And at Cisco, I was head of product for Cisco's cloud business unit. So I was overseeing initiatives from Cisco around containers, Kubernetes, OpenStack, container networking, and a few other teams and initiatives. So I've been following this cloud native development landscape since almost the beginning of the Docker days. And one of the things that we have gotten good at as an industry is over the last 7-8 years, we've mastered CI and CD to an extent, where we can continuously build applications, have automated tests that test for functionality of the application to make sure that it's working right, have automated tests in many cases to test for performance of the application to make sure that it's working with acceptable performance, and then lacking confidence all the way at the end to use continuous delivery to push the releases to production. The missing piece there was we as an industry, as an engineering team, because every company is a software company. So as you build software and you're now trying to build cloud native software, which allows you to build things really, really fast, we are building them fast, checking for functionality and performance really fast. What we're stopping when it comes to checking security and compliance. And because of that, we're not able to push it to production as fast as we can. So one of the reasons why I left Cisco is because I wanted to start DeepFactor to give the engineering teams the capability to identify security and compliance risks during the course of development and bring it on par with how we're able to do CI and continuous automation and so on and so forth. So our goal with DeepFactor is to create essentially that developer security platform that enables engineering teams to create secure and compliant applications. And there's a few things that I felt were lacking in the industry that we've really made sure that are unique things about DeepFactor. Number one, we wanted to make sure that this developer security platform is designed with a cloud native first mindset. That means you've got to plug into Kubernetes, you've got to plug into your container infrastructures very easily, no agents, no sidecars, and so on and so forth. Number two, you've got to make sure that you observe a running containerized application. Because in these days, with cloud native applications, there's multiple containers that are running in your, that make up your surface area of your application. So you've got to be able to observe every thread, every process, every container pod that is running in your Kubernetes clusters that you care about, so that you can then hone in and provide application-aware insights that basically tell you, give you comprehensive visibility into security, supply chain, as well as compliance of your application, without asking your developer teams to use like a bunch of different tools for different aspects of your security posture. And then observing running applications should help you point to the actual problem, including like pointing all the way down to, here's the tactics, here's a rich piece of evidence that will allow you to resolve the problem. And then prioritize the problem based on usage so you don't get drowned by alert fatigue. So essentially, bake it into your dev, test, CI/CD pipeline. And regardless of whatever AppSec testing tooling that your AppSec team, if it's a separate team, might be using, ensure that you as an engineering team are creating a secure and compliant product to begin with. So that's kind of what led me to starting DeepFactor. And in that process, I gave you a bit of an overview of what DeepFactor is as well.
Yeah, and I appreciate that. And I think the thing that you're highlighting here is in a roundabout way, DeepFactor acknowledged that there was an opportunity to go after the DevSecOps sort of part of the market, right? To really lean into the idea of implementing that and shifting left. And, Jim, I'm really curious, given your experience on the other, not the other side, but kind of other side a little bit higher up as a CISO, can you give us your impressions on that sort of transition to DevSecOps and maybe kind of connect the dots and what Kiran was describing, the challenge that he identified as a product leader at Cisco and what you were seeing as a leader in the security space? Where did that sort of transition start to happen, the acknowledgement that DevSecOps and identifying, security champions inside your development team was the best way to go about sort of shifting left?
Yeah, there were three things, Andrew. So the first is, and this is really important for enterprises that have legacy infrastructures building on-prem applications. And every enterprise I've worked with kind of fits in that category. And the first thing to consider is that cloud-first software development is fundamentally different from on-prem software development. Now, the differences are largely in the role and responsibility of the developer in the cloud-first model. It's fundamentally different than the role of a developer in an on-prem model. In an on-prem model, the environment is provided for the developer. In a cloud-first model, the developer is influencing in a DevOps team, influencing the configuration of the build process and the tools that are used, and actually writing code that's doing what infrastructure did in an on-prem world. And they're thinking about all sorts of things from a security perspective that they didn't have to worry, that were provided for them in the on-prem world. So the first thing to remember is that the generation of software security tool and capability that exists today in the marketplace largely came from on-prem software development. And so in a cloud-first model, recognizing the differences in software development, you need some different tools, different capabilities that are embedded into your build process. And as Kiran pointed out, in some cases, we could be far more efficient and effective at building quality software if we use the tools and capabilities that are available, but we have to recognize that they're different from what we did in the on-prem world. The second thing that enterprises have to come to grips with, and this is for a lot of enterprises that built a software security or an application security team separate and distinct from the DevOps and the developer teams, and they made them accountable for the quality of software that was produced, essentially related to the defects, security defects. That's absolutely the wrong model. So scrap it and don't do it. I know it sounds binary, but there's really no foundation in that model, and here's why. What's essential in an enterprise is establishing who has accountability for what, and then reinforcing that accountability. So this is one of those principles that you have to hang your hat on. If you develop software, you're accountable for the quality of the software that you produce. So whatever role you play in the process of software development, you're accountable for the quality of the software. Now, that's pretty easy to get developers to buy into, to get DevOps teams to buy into, and frankly, to get the organization to buy in. What's really confusing is when you say, yeah, developers, you're responsible for the quality of what you produce, and this other team's responsible for the security of what you produce. First of all, it causes unnecessary friction. Second of all, it's fundamentally wrong because most of the time, the cybersecurity professionals that are trying to do their job from a software development perspective really don't understand the nuances of cloud-first development, and they're at a disadvantage. So a better model is to say, software developers, you're responsible for quality. By the way, quality includes resilience. By the way, a big part of resilience is security. And that's the responsibility of the developer or the DevOps teams. It's not the responsibility of anybody else.
You're arguing the semantics of quality at that point, right? And that's not what you want to be doing.
That's exactly right. And you know what? There's a really good economic business case for doing exactly what I'm saying. Drive accountability where it already is, and that's with the DevOps and the software development teams. That's where it has to be. The software security teams or the application testing teams or whatever cybersecurity folks are calling themselves in a role, they are responsible for identifying the control and tools that can be used in the development process and then capturing the key performance indicator information on how successful those products, tools, and capabilities are in whatever build process is used by the enterprise. So there's a critical and essential role that they play, but they are not accountable for the end result. You have to make the owners of the software development process accountable for the end result. Now, the companies that I work for spend billions of dollars on software development a year. I mean, a lot of money. And so there's a good economic argument for this accountability model that I'm talking about. Because if I'm a software developer and I can improve the quality and the resiliency of the software that I produce, then I can actually do it at a lower cost, a lower total cost of ownership, because that total cost of ownership goes down when the quality of the software goes up. And it doesn't go down a little, it goes down a lot. And in fact, if you replicate that across the entire enterprise, you're talking about a potential of hundreds of millions of dollars in productivity gain and lower cost that an enterprise can realize simply by embracing this idea of enforcement of accountability, of quality to anybody that develops and touches software in an enterprise. If you do that, you can worry a lot less about compliance. If you can improve quality systemically across your software stack, then the benefits, the cost benefits and the productivity gains become the incentive for higher quality practices. And you create a continuous way of driving improvement across the enterprise.
Yeah, I really like that. Kiran, did you have something to say in the middle of that? I thought I heard you trying to jump in.
No, I completely agree with the points that Jim mentioned, especially the second point around development teams who are building software as they take ownership of what they produce. The ownership around quality and performance is very clear today, but the ownership around security and compliance has been murky, but it's been changing. And that's the change that we're all welcoming.
Yeah. And I think what I appreciate is what I feel like we're getting at is almost like changing the culture in the way that a business decides that they want to go after sort of security or really strike the balance between security and development. Jim, I'll come back to you because I want to understand your perspective on the people aspect, right? How do you change that culture? Kiran, really quickly, you mentioned when you were talking about DeepFactor a little bit about some of the tools and sort of decisions that you need to make. And I know Jim kind of backed it up by saying the person that's accountable for the ultimate security of the application should have a stake in choosing the tool set and developing that sort of security pipeline. So I'm kind of curious about changing culture, but by changing the technical implementation of how you do security for your applications. Can you kind of speak to that and what sort of decisions that developers and VPs of engineering need to be kind of thinking about when they're reevaluating their security pipeline for cloud native applications, with, of course, the end goal being a change in culture, right? I think that's the most important thing, is identifying how you can get to this end state of developers owning AppSec to some degree and making them feel like they're a crucial part of that sort of process.
Yeah. No, I guess just to give you a more kind of lighthearted example to convey the process point. My daughter hates brushing her teeth, right? So at night when she finishes brushing, I go and check if she did a good job. So if engineering teams are, in this example, my daughter kind of brushing, not wanting to brush her teeth, not wanting to check for your security of your applications. I'm not saying that's the case with engineering teams, but just go with me for a second. Then an external entity, which in this case handles the AppSec function, is the one that is verifying. So unless, and that's not going to scale. So unless the engineering teams kind of take responsibility for making sure that the security posture of their own applications is verified, in this case, my daughter brushing her teeth, if they do that, then the chances of getting breached, which is getting cavities for my daughter in the future, is significantly reduced. Or the chances of you passing when you go for your 6-month dentist appointment, compliance checks, you will pass that with flying colors. So basically, keep the ownership where the product's being produced. And in order for that kind of a cultural component to be driven into the company, that is probably one of the fundamental tenets that need to be baked into the engineering teams. Now, it is changing.
So you're saying let the engineering team pick their toothpaste and let them pick their toothbrush. Is that kind of the goal here?
Exactly. That's a lighthearted way of saying, make sure that there's because process is very tightly tied to the tooling. And the moment you say, I will let my application security team, which is an external entity, depending on how your organization is structured, pick a set of tooling to determine the security posture. They are subject matter experts in security for sure, so it totally makes sense for them to do a sanity check by using the tools that they want at an Uber level, at a, all of the list of applications level. But for a developer, when the developer is building their application, I think they don't care about how the other applications are, whether they're secure or not. They care about their application that they're building. So their specific microservice that they're building. So how is that microservice running? What tools are we using? And the tools, as long as they're seamlessly plugged into your CI/CD pipeline, make sure that you automate them. Make sure that you pick a set of tools for engineering. I think this is where engineering leadership needs to step in and make sure that the process for triaging is as seamless as possible to the engineers, so that as soon as they check in code, builds get created, builds automatically get verified. They're running as part of their automated test framework. And while that's happening, watch your applications, get the feedback, and seamlessly convey in your CI/CD pipeline itself that, hey, the code that you checked in last night, you brought in a third party, and that third party is making an outbound connection to a certain geography. Let's say, for example, Hong Kong, and did you intend for that to happen? If not, you may want to go fix that library, right? That kind of feedback during development is super helpful.
Yeah, you're highlighting it's something that our CMO did a really good blog on is you're actually highlighting industry trends as well for these tools. Gartner is identifying a new category of tools called the Cloud Native Application Protection Platform. And really what it is, it's the marrying of the traditional AppSec tools, scanners that developers have been known to use, and then this sort of like workload protection where you look at the Kubernetes sort of runtime protection. And really all the category is just kind of a marrying of those two different concepts. And you're seeing some tools that have been traditionally used by AppSec and operators kind of try to come over to the developer world, but you're still in a way kind of enforcing your way of viewing things on the development organization. You've got these tools that were predominantly designed for operators and for AppSec, people in those organizations, and they're not really meant for the developer themselves to kind of parse and use as they're developing. So you're really highlighting this trend that we're seeing in the industry just from a tooling perspective. Jim, I wanted to jump back to you now. We've talked about the tooling, we've talked about the process. I think Kiran highlighted some really good points there. What about the culture, the people aspect of identifying security champions in your development team?
Yeah, I think first and foremost, I'm going to say a couple of controversial things, but
we look forward to that. Yes.
That's really what I believe. There's this perception in the cybersecurity realm, primarily large enterprise cybersecurity teams have a perception that software developers resist the use of tools and techniques for cyber resilience. And they don't understand cybersecurity, and they don't want to, or they wish to understand cybersecurity. And it's wrong. It's just fundamentally wrong. Actually, DevOps teams that have any kind of experience with building a pipeline effectively, they embrace security. They have no qualms about stepping up to the accountability of including security as an attribute of quality in what they do. The disconnect is mostly with the cybersecurity teams that are promoting the use of tools that are obsolete for a cloud development, a cloud-first development model. And so let's stop calling them tools. Let's call it instrumentation. So what we're doing is establishing a build process and a pipeline that we want to automate as much as possible. And in order to do that, we have to instrument that pipeline and that build process leading to the pipeline. And the instrumentation will change and evolve over time, but the primary focus is quality with resiliency baked into that, accountable for the teams that are doing the work. So if I'm a cybersecurity professional, number one, I want to step up to the plate and say, I'm anxious to learn from your experience. Number two, I want to say, I'm anxious to help with your experience. And number three, I want this to be a core competency and capability of you and your team, and I'll do whatever I have to do as part of the team to make that successful. Now, there's this long tradition, compliance-oriented security has this baked in spades of somebody does work and somebody checks the work. And that's kind of embedded in the mindset of a lot of cybersecurity. Hey, look, I'm not responsible for the software, but I'll check the quality of the software. I'll check whether it's compliant or not. And again, this is not constructive or helpful in the culture that we're trying to establish. The culture is a DevOps culture, and accountability for resiliency of software is embedded in that DevOps culture. And the instrumentation that we choose will evolve over time as we get better at being more effective and efficient in the build process and the pipeline. Ultimately, we want to get to a point where there's so much automation in the build process that we can move to releases of full stack software capability on an hourly basis, literally rebuilding our code for digital assets if we have to on an hourly basis. Now, daily is a huge stretch from where we are today. In some cases, weekly is a big stretch. And lots of organizations would be really happy with quarterly, releases from where they are today. But ultimately, the direction we want to go is to have a level of automation that gets us to hourly builds. And that's an aspiration at this point. But that's why I say with that kind of vision, you have to be flexible in looking at the instrumentation requirements as they change and evolve in the process.
Anything to add there, Kiran?
Yeah, no, I mean, can't agree more. The instrumentation is key, and the instrumentation basically has to be seamless in such a way that devs don't even see that it exists, right? It's a tool that developers like and use, but the way the insights are provided to them should be non-disruptive to them, because they can focus on shipping features fast, because that is the goal of most developers anyway. But if there's a security issue, if it is treated as all the way from the point of sprint planning, if security-related items are treated as its own section in the sprint planning document itself, just alongside your functionality improvements and performance capabilities, then that can go a long way in making sure that this culture of embedding security into your engineering teams itself is influenced and is imposed properly.
Yeah, I remember when I was a product manager, one of the things I try to implement is when you write your features out, you always talk about like what is the objectives for completeness, right? What sort of features do you walk through? Well, security should be a component of that, right? I should not be able to, you should put this through a linter, so I shouldn't be able to do certain things with the the inputs and stuff like that. Those are that should be part of the definition of done. So that's a great call out there, Kiran. As these organizations kind of communicate, Jim, do you feel like it is a problem that needs to be solved top down, where the CISO and VPs of engineering are kind of coming up with a strategy to kind of encourage this sort of evolution, or do you think it's something that's naturally going to occur as more and more people kind of come to the table and agree, hey, we have a common objective here, we want to operate at a certain pace, so we need to reevaluate our tool chains, we need to kind of work together to do this? Do you see this organically happening, or do you think it needs to be a directive?
Both. And the reason I say both is it's happening, right? And by the way, these are natural forces that are driving this change process, largely due to economics and the efficiency, effectiveness of cloud capability in the enterprise as a computing platform today. So these things are happening on the ground. And by the way, they have to be solved on the ground because, oh yeah, that's where accountability is in the DevOps teams. That's where these things have to get solved. However, a top-down acknowledgement and recognition of what that transformation process is and the support necessary to enforce it makes it happen with a lot less friction and makes it much more effective and easier to measure. And the problem isn't a lack of will at the senior levels. It's actually a lack of understanding of the differences in a cloud-first model. And I think if they grow in that understanding by understanding actually tactically how it's done at the ground level, they'll actually develop a better appreciation for adjustments in their thinking in order to drive this accountability model effectively. And so I think it's both. I think you you're already getting the tactical hand-to-hand combat, that's happening today between cybersecurity teams and DevOps teams. And I think that has to be a construct where they're collaborative and enforcing that accountability model for the DevOps teams. And that has to be recognized by senior leaders who are promoting and supporting that, and ultimately driving quality and efficiency across the enterprise, which is what senior leaders are supposed to do.
Yeah. So everyone gets an OKR is what we're saying. It's not, it's everyone is going to have a stake in the sort of the outcome of this. I'm curious, we've talked a lot about the positives. I think, there's a lot of good reasons why you want to move in this direction as an organization, just to play the other side of the fence. Is there a downside? Are there any sort of speed bumps that should be anticipated? Anything that would get in the way of sort of migrating to this sort of DevSecOps sort of model? Is there anything that comes to mind that people are going to have to navigate as they start to make this transition that's going to be very challenging for them?
Cybersecurity professionals, and this is a generalization, have often been limited in their understanding of software development practices, any software development practices. They read about it, they kind of look at artifacts, they study the after effects, but in most cases they were not software developers. And that's not, by the way, essential. What is essential is that they at least understand the software development process. Now, that was in the on-prem world. In the cloud-first world, they're at a real disadvantage. And so as a cybersecurity leader, we have to recognize that there's some retooling that's required for cybersecurity professionals that are involved in the software development process. And you said this earlier, Andrew, software is kind of eating the world. So we all are. We're all about software and software development, no matter what enterprise that you work in. And there's a lot of truth to that. And so as cybersecurity professionals, we have to get a better appreciation for what does this new, build pipeline process actually look like in a CI/CD world, and kind of how we're targeting the future for software development as an enterprise. And therefore, what do I, as a cybersecurity professional, how can I contribute? How can I help with this process? And I think if cybersecurity professionals have the notion of, I need to get educated in order to understand this at a level of detail where I can provide value, that commitment will actually mirror a commitment that developers already show today in trying to understand how to put guardrails in place to make this process a lot more efficient. And by the way, they're making mistakes doing it because we're human and we're going to make mistakes when we learn new things, and that's normal. So I think both the cybersecurity professional and the enterprise has to recognize there's some retooling necessary, and leaders have to recognize that this is a transformational process and it's a cultural change across the enterprise, and they need to be transformational leaders and leading the charge.
Yeah, we actually did. Kiran and I did a couple of meetups, kind of focused on why digital transformation should include your application security tooling, because we, in our many conversations, would come across cybersecurity professionals who didn't quite understand that concept. They weren't ready to accept that in this new world of cloud native applications, cloud environments, cloud infrastructure, the operating pace at which things are being developed, that, throwing a firewall or putting a WAF out there, or using VLANs to separate things out was no longer going to just cut it, right? That was no longer going to solve all your sort of application security problems. And so that you needed to reevaluate your pipeline. So that's interesting that you also highlight that as well, for sure. So we're coming up towards the end of the hour, and I know that we need to leave Cody a little bit of time to close things. So I kind of want to move into a little bit of a conclusion. Kiran, I want you to tell me something that you learned from Jim today.
The thing that I learned today was, incident response is a gift. I'm going to write that down. And I think it's so true. Like anytime there's something that doesn't go well, I think learning from it, documenting from it, and becoming a better organization the next time around is extremely important. So I learned that, and I'm gonna write that phrase down. Incident response is a gift.
That's great. I think if you marry that with a blameless post-mortem, you'll just have this holy grail of learning that you can be that can be done. If you're not worrying about blaming people and you use it as an opportunity to learn what might have gone wrong, there's a lot of learning that can go around. Assuming that you can handle, not firing someone as a result of the security incident. So
I'll keep that in mind, Andrew. I think your performance evaluations.
I know, right? I'm just trying to plug that, hey, by the way, Jim, what is
hey, Kiran, on that note, in his performance evaluation, make it clear to him that he should not use the term post-mortem. That's a term that has no relevance. It's lessons learned, and real-time lessons learned are better than after-the-fact lessons learned. So, because that's something that we were like, okay, let's do a post-mortem. I'm pretty sure post-mortem, I remember my Latin, means after death. I'm pretty sure that's what it means. So the whole point is you can learn from others that, that have experienced an incident, and we should just forget the whole death metaphor and just go with lessons learned.
That's fair. That's fair. I like that. Jim, what is something you learned from Kiran today?
So I'm a big believer in taking complex problems that face the industry and face enterprise to protect enterprise assets and trying to make it simple so that you can communicate to a broader audience and have some level of connection with the message. So I've never, ever used oral hygiene as a metaphor for cybersecurity resilience. Kiran introduced me that today, and I'm forever grateful because I see a lot of parallels there of making the message simple. Oral hygiene is something that if you don't do well and you don't own it because it's your mouth, you're going to have lots of problems down the road and more and more visits to the dentist chair. And so there's a lot to be learned from that. So Kiran, thank you.
Absolutely. My daughter's going to be happy.
I have found that those, what's the word I'm looking for? Those, analogies work very well, right? When you're trying to explain this sort of concept to people. And I think that's great. It resonates with people. I think for a long time we talked about, you wouldn't buy a car that you couldn't test drive kind of thing. And then COVID happened and we realized that there's a lot of people buying cars without test driving them, right? So that analogy kind of had to go away. So we did have a couple questions come in over the course of the presentation. I want to give a chance to answer them. So we did have a question that I think is going to go to you, Jim. What's an example of a real-time lessons learned rather than or in addition to an after-the-fact step? So is that implying that we should try to ask the question mid-incident?
Yeah, and so it's a great question. I'm actually going to respond to this in the section. I was just starting to type it out, just so perfect. You have this so you don't have to write it down. But there are 5 steps in a cybersecurity incident response process that you should incorporate. Now, I understand that there's a lot of documentation and literature around cybersecurity incident response. You won't find these 5 steps verbatim defined anywhere. Unfortunately, they should be, but they're not. So these are the steps. The first is facts. And the reason for that is how many times have everyone got onto a call following some sort of incident, whether it's an IT incident or a cybersecurity incident, and the first thing you have to do is figure out where the conversation is and how long those people have been on the call having that conversation. And it takes about 10 or 15 minutes before you orientate yourself to understand all the information that you can actually make a contribution. So the first thing that should be done are address the facts. What are the facts as they're known? And facts are not opinion. It's just the facts and as concise as possible. And frankly, document them as you go so other people that get brought into the incident understand facts. Second, what's the business impact? Who's impacted and what is that impact? Third, what's the root cause? How did this incident occur? And if we don't know the root cause, identify a hypothesis. And that hypothesis then has to be proven or disproven with data. So at any point in time, you may not know all of the facts. You may not know all of the impact, but whatever you know, you put down, you document for anybody that gets involved in the incident going forward that they know. Okay, fourth, corrective actions. The key to corrective actions is there has to be an owner and a target, like a today, tomorrow, next week, next month, a time frame, owner and a target for every corrective action. So the accountability is clear. And the last one are the lessons learned. And lessons learned, first of all 5 categories should be populated when you have the data. So if you don't have the data, you don't include it. If you have partial data, you include that partial data. As you learn more information and get more data, you add to that data. And so lessons learned should start out right from the get-go. Oh, you know what? Maybe we should enforce multi-factor authentication on our repo, our repo management system, GitHub, GitLab, whatever we're using, right? Maybe we should do, oh, by the way, they now offer that capability. Here's a lesson learned that we can apply today. We don't have to solve this incident and then do it. We can do it today. We can do it right now. That's a lesson learned. And that's the beauty of not doing post-mortem after the incident, but during the incident, applying the lessons learned when you can apply it. So 5-step approach. I'll put it in the notes so you have it. But if I were you, when you practice cybersecurity incidents, follow this process. Use the 5-step. When you get people on calls in the middle of the night and you've documented these 5 steps, people are going to be much more proactive and can make a contribution earlier if you share this information.
That's a great answer, and thank you for providing that in the chat. We also had another question, and Kiran, I'll give it to you. It's a little bit of a speed round. We had 2 questions come in, and I think they're kind of related. So the first question was, you mentioned earlier that some of the traditional AppSec tools are not necessarily made for cloud native applications. And I think this person wanted to understand, what does that mean, right? And then we had another question come in that's a little bit related. It's how do you approach cybersecurity and AppSec leadership about changing the security tools and articulating that they aren't necessarily good enough for what you're trying to do. So I think those are kind of related. How do you actually why are the older tools, the legacy tools, not good for cloud native applications? And then I think the follow-up question is, how do you then approach leadership about that sort of deficiency and get them to change the tooling?
Yeah. So let me take the first part first, which is, why do you need a different set of tooling for when it comes to cloud native applications? Let's think about what cloud native applications are. They are a monolithic application that used to be the case in the past, broken down into a set of microservices. Each microservices does a separate thing. It is probably managed by a different team, depending on the size of the microservice, the number and the size of your organization. It's probably written in different languages, because one of your services could be written in Java, one in Node.js, one in Golang, or some of them could be written by your guys. Some of them could be some of them could be third-party containers. So they all make up your application. So a reasonable application, cloud native application today, it's not uncommon for that application to have tens of containers. Now, if you use traditional application tools that don't, AppSec tooling, that don't even understand Kubernetes, that were designed before Kubernetes even existed, then you're first of all missing out on the visibility that you're getting when it comes to cloud native applications, because the attack surface has changed quite a bit. The support for different languages and different third-party usage, which has increased significantly, is not going to happen. Plus, there's different ways in which your attack surface is changing today, because as infrastructure, with cloud native applications, another thing that has happened is infrastructure has become more immutable. Therefore, the attack surface has moved more and more to the application layer. So the onus is on you to make sure that your application is secure. So given all of this changing breadth of your containers, your application surface area, and the attack surface kind of moving and changing, generally speaking, you want to make sure that you look both at your static artifacts, your container images, your dependencies, etc., such as is log4j present. But also, it's important to understand the running behavior of the application. Did you developer bring in a third party that has a root access, or that is running as root, or that is elevating its permissions, or that is making an outbound connection to Hong Kong, the example that I gave you before? Or are your services between the two, each of them exchanging secrets and clear text? Those are all the types of things that cannot be caught with traditional tools. you need a cloud-native oriented security platform and a developer-oriented security platform. And that's, in a sense, why tools like DeepFactor have emerged. Now, the second part of your question is,
yeah, I think Jim's answering it a little bit in the QA. I know that we need to wrap it up, so I hate to cut you short. Cody, one quick second before you jump back in, I want to point everyone to the very top of the QA and chat box. There is a Forrester report that DeepFactor is providing. It is about developer security champions and how to kind of work that culture into your organization. It's a very, very good read. I highly recommend that you give it a look. With that, Jim, thank you so much. Kiran, thank you so much. It's been a great conversation. I know there's a lot of information here that is going to be extremely useful for people. I know I will be re-listening. Cody, go ahead and close us out.
Hey, thank you so much, Andrew. And thank you to Jim and Kiran as well for being here with us today and providing us an in-depth discussion that we don't often hear from a lot. So thank you guys so much for being here with us today. Quick reminder, today's session was recorded. So after the webinar concludes, you'll receive a link via email to access the on-demand recording. Quickly, we need to announce our 4 Amazon gift card winners. Our first winner is Tobias B. Our second winner is Kimberly K. Our third winner is Tim D. And our fourth winner is Srini M. So congratulations. Keep an eye on your inbox to claim that gift card. And if you don't find that email, just check your spam folder. I'd like to thank DeepFactor for sponsoring today's webinar. And my final thanks goes to you, our audience, for being here with us for today's discussion. Have a great rest of your day, and please take a second to fill out our post-webinar survey. Thanks, everyone. We hope to see you at a future TechStrong webinar.
Thank you.
Thank you, everyone.